Alright, we're looking at 2.5, solving problems involving rates of change. So looking at example 1, you're asked to show that a maximum value for the function f at x equals negative x squared plus 4x minus 21 happens when x equals 2. So you need to show that a maximum value happens. What does that mean? Well, when we think about a maximum, let's look at a little sketch here in the corner. When we look at a maximum, looking at that, what happens at a maximum? What do we know about that maximum value? What can you tell me about, for example, the tangent? Let's say I had the maximum value right here. What would the tangent be like? Well, if you think about it, I'm going to bring it across a line, and this line I'm going to bring across. Now, if I take this line, and let's say I grab him, and I move him, okay, across here. What happens is that this would be considered a tangent somewhere along the curve over here. But as I get closer and closer, what's going to happen to my line? Well, my line is going to move. It's going to move in such a way that I'm going to take, remember I took that line, and I'm going to move him. What happens to him as I move him? Well, he's going to have to turn, and he's going to turn in such a way that this line is now going to be a tangent. So what kind of line are we looking at when it's the tangent line going through that maximum value? Well, folks, that's going to have a slope of 0. So this here, this function right here, has a slope of 0. This tangent line that we're looking at right up here has a slope of 0. So we need to be able to prove the slope of 0. How are we going to do that? Well, let's see. We're going to take delta f over delta x, and we're going to find the delta f at delta x for a very small interval. And we use the difference quotient formula, and we get delta f over delta x at x equals 2 is going to be the following. And when you expand it, what's going to happen? Whoops. When you plug in x equals 2 and you plug it into the equation, now how come we have, just be careful here, you might be wondering why in the world do we have this 2 negative 17? Where did that come from? This 2 negative 17 over here. Remember, if x is 2, what's the y value? So f at 2 is going to be, when you plug it in, negative 17. So when I plug it into here, this will be f at 2, when we substitute x equals 2, so I just put in negative 17. Negative negative makes plus 17, so that's where the plus 17 came from. Let's continue on, expand it, and you end up with a value such that, okay, let's look at that. So what we're going to do here, look here, we're going to have to expand this, and then we're going to collect like terms. What are we going to get here when we do all that? Well, here it is, the statement again. And what we're going to do is expand it, collect like terms, and lo and behold, we get negative h squared over h. Why is it negative h squared? Well, the minus 4h and the plus 4h disappear. The minus 4 plus 8 is positive 4, minus 21 is negative 17, plus 17 is 0. So all we're left with is negative h squared. Well, we know that negative h squared over h is going to equal negative h. Now, since we replace h with a very, very small number, i.e. 0.0001, or a small number that essentially is 0, the resulting slope will be 0. So we're going to let h equal a very, very, very small number, or let's say 0.001, and so delta f over delta x is going to approximately equal, once we plug in that value, it's going to be very, very close to 0. It's like negative 0.001, which is essentially 0. Now, so that means the resulting slope will be 0. What do we do next? We've proven that it is a horizontal line at x equals 2. So we need to move forwards from that. What we need to do is check the points on either side. So we can continue a table and check the points on either side. We know what f at 2 is, so what we can do is check the points on either side. What does that mean? That means that when we look at this, and I'm just going to erase this so that we can find some room here without going to a new page. Just going to erase this, and once we let h equal 0.001, and we know that the delta y over delta x is 0, we find the values before and after 2, -17, and what we find out is that 2, -17, this is the point at where the maximum occurs. So that's your maximum. All right, this is your maximum. We know it's going to be a maximum because on either side, this value right here and this value right here, remember these are the same values because they're on either side of the parabola. So if you think about it, we're going to take a secant point before and a secant point after. Think of preceding and following. We take a secant point before, take a secant point after, and what happens is these values are going to be the same only because it's a parabola. It is not the case if it's a cubic or something else. Needless to say, these numbers are actually lower than -17, and that means since these numbers are lower, okay, so let's write the word lower, okay, we know that it's a maximum because those values are lower. All right, and this graph here is just an example of another case where you might have a cubic going on, so it could be a maximum or minimum. In a quadratic, we've told you up until now that if there's a negative in the front, it opens down. If the positive, it opens up. Well, here you're proving it, and that's what we're showing here. Let's look at another way that we can do a question like this. Example number 2. Show that at x equals 0, for f at x equals 3x squared plus 2, is either a maximum or minimum. So you're asked to show that. So let's prove it. How do we prove it? Well, calculate delta f over delta x for a general point. At x equals 0, we find out that this is going to be what it equals. When x equals 0. Now some of you are going, how did the h go? Where did the 0 and all of this? Where did the bracket go? Let's look at this again, folks. X plus h, we want x to be 0, so this is going to be 0 plus h. What is 0 plus h? It is just h. So I'm going to plug in h, 3h squared plus 2, minus 3 times 0 squared plus 2. We get delta f over delta x is equal to 3h squared over h. Why is that the case? Let's look over here, 3h squared plus 2. This is going to be minus 2, so because we subtract the 2 plus 2, that becomes 0. We have 3h squared over h, which equals 3h. So we let h represent a very, very small number, and that tells us that delta f over delta x is literally approaching or getting really, really close to the value approximately 0. So this means that right here we have a tangent, a slope of a tangent of 0. That means that this is either a maximum or minimum because the slope of the tangent is 0. So how do we prove if it's a max or min on either side? Well, folks, let's try and do it without points. Let's look at the secant. So the tangent is a horizontal line. So let's look at the preceding and the following. From 0, we look at a point very close to 0, a secant value on the preceding part, which is negative 0.1 and 0. So we're looking at a preceding value interval and a following interval. And what that's going to do is we're going to look at whether it's a maximum or minimum. Why? Let me just show you a diagram so that you can understand this. If it's a maximum or minimum, what we have here is basically a horizontal line. And we're going to look at the secants on either side of this value. If we look at the secant value on either side, these secants are either going to go like this, the secants are going to go like this, or depending on which way we're looking at it, like this. So the idea, what we're actually doing here, folks, is we're trying to find whether it's a max or minimum depending on the slope. So using slopes, slopes of a secant. So we do this by doing the following. We find the average rate of change at negative 0.1, and we plug it in. So we plug the average rate of change, and we get a value of negative 0.3. We do the following part. We get a value of positive 0.3. What does that mean? Well, the slope preceding 0 is negative, the slope of the secant. The slope of the secant following 0 is positive. Therefore, 0, 2 must be a minimum. So again, let me just draw it out for you. So if I have a horizontal line as such, and I'm going to now draw, a horizontal line. All right, let's try that one more time. A horizontal line, and I'm going to draw a slope that is negative. So a slope that's negative goes down like this. And then at that same point, I'm going to draw another slope that is positive like this. What kind of point are we talking about? Well, if it's a curve that we're talking about, what's happening on that curve is this curve is actually hitting this point, okay, as a minimum. So what we've got here, folks, is a minimum. Now, I want you to look very carefully, just for a second, back on the previous question. I want you to look at the answer here, right here, this answer over here, and this answer over here. So let me circle those for you. So we're looking at these answers, and I want to see if you can see how we could have gotten these answers in one step. We still would have to write this preceding and following intervals, but how we could find the average rate of change, so the slope of the secant, in one step. Let's look at the previous question. Remember earlier we had gotten this formula before we actually substituted our h value? Do you remember this value is 3h? H represents a interval, a certain amount of interval. Normally, for a tangent, all we look at is 0.001. But we can actually use this formula for a secant. Let's look at the next one and see what I mean. If I had 3h, and I knew my general equation was 3h, okay, let's use 3h here. That's my general equation. Well, how much is this interval going over here? How much is this interval up here? That's what we're trying to find here. What is this interval? From 0, it's going to negative 0.1. If I plug in negative 0.1, because that's the distance from 0 we're moving, the interval we're moving from 0, if I plug in negative 0.1, guess what, folks? We get negative 0.3. The same goes for the following. If I know this is my interval, which I have to use, and I say h is equal to 0.1, positive, because we're going to the following part, I plug in 0.1 for my h, because that's my interval. Guess what, folks? That gives us the slope of the secant for the line at when x equals 0. So funny enough, we can use that general formula we found on the previous page to answer our secants on this line. Cool, eh? All right then, that's the end of the unit, folks. Take care. Good luck.